Right, so welcome to our first class for the year 2026, and we're looking at conic sections. So, yeah, you can say conic sections or just conics. You can call it a conic. Okay, so a conic section or just conics, whatever you'd want to use. So, what is this? So, in mathematics, a conic section is a curve that is obtained as the intersection of the surface of a cone with a plane. Okay, so now you have to follow this very carefully. So we're saying this conic section is just an intersection between a surface of a cone with with a plane. Surface of a cone with a plane. As you can see in these diagrams that are down here, we have this plane that is in blue is cutting through the surface of these cones that you see here. So we have, this is just a double napped cone. That means you have one facing up and the other one facing down. It's just two cones in short. And then through these cones, you see there's this axis here. That's the axis of rotation that is going through that point. So that is just the axis of rotation. And then, of course, you have your plane. So now the conic section, as we said, when this plane cuts through the surface of this cone, then it's going to form a conic section. Hence the name conic sections, because you're making a section or a cut through through a cone. So now basically there are three main types. Then we extend it to four. So these types we have the hyperbola, the parabola, the ellipse, and of course we are talking of the circle also. Now, notice that you will not look at the circle that much, but then the understanding of it is important, not only for this course, but might also help you in other courses. So, this is the only part that we will look at today. We will look at the circle. Don't worry, as I said, our class today is brief and short because we're just looking at at the circle. But then we, of course, because we have two parts here, we're doing the live and recorded. A recorded class will be shared also for you to understand better. So you have a parabola. So the first one, so I'll explain this step by steps on an overview of what each is. So what is a circle? So before I look at exactly the formal definition of what a circle is, we'll look at it from this diagram here. So from the diagram, our circle is just this curve that is formed. So you can see this round curve here that is formed. So a circle, of course, you know, it just looks like that. That's a circle. So it is formed when this plane goes through Goes through this cone at At a, uh, at a, at a perpendicular to the axis of Of rotation. So when it is perpendicular to the axis of rotation, the plane being the axis of rotation, you say this line going through there, you see that it is perpendicular because my plane is cutting like that and my axis is going like that. So it forms a 90 degrees. So it being perpendicular like that. So this cut there, when it's like that, it will form a circle. Then you have that when this first part here, the parabola. So the way I am explaining them is how we'll look at them in details. That is this class circle, the next class that will be shared, that is going to be looking at parabolas. So now, when this plane cuts cuts this cone parallel to the side of the cone. So you see that your cone, if it was in 2D, it would be looking like this, which is just like a triangle. So now when you cut here, the way it's cut like this, it's perpendicular, or I mean it's parallel to the side, which is this side, like that. So you see that the plane and that side of of the cone are going in the same direction. Then when it cuts through the cone, which is down, this shape which is formed here, like that. That shape there is what we call a parabola. So that's a parabola. So again, in formal definition, we'll look at the formal definitions when we get to the actual part. And for this class or for our classes, when you just have anything to say, just unmute yourself and speak and ask. Yes, so then when you look at an ellipse, so what is an ellipse? So an ellipse, in this case, we are cutting our cone at an angle. We're cutting our cone at an angle. That angle, of course, that is going to be made with this when this axis of rotation here, like that, and where we're going to cut that angle here, this angle should be always less than what? Less than 90 degrees. So if we cut it at that angle there, then it's going to form an ellipse. So an ellipse is more of a stretched out circle. So it looks something like that, something like oval shape. That's what an ellipse is. And then you have this parabola. So the parabola is just these, there are these two curves that are formed. There's this curve and there's another curve here, like that. So when your plane goes through these cones, cutting both at such angles where you have one formed like there on top and one formed like that there, this like that facing each other that direction, then it's a hyperbola. Then it's a what? Hyperbola. So each of these can be described by what? By an equation, which is exactly what we're going to look at next. Okay, so they are telling us describe the conic section given by the equation. So now, one thing you must notice is, one thing to take note of is you have A. So I'm going to, okay, just a minute. Right. So as I was saying, that each of these conic sections can actually be written as an equation. And that equation, so in this case, they're telling us describe the conic section given by the what? By the equation. Conic section given by the what? By the equation. So then what they're telling us is we must be able to get this equation, then we must manipulate it, and then after manipulating it, we must what? We must find or identify what type of what type of curve does this equation belong to. So the general form of each conic section where we're going to have it, the general form is a x squared, like that, plus b xy, and then plus c y squared plus dx plus ey, then plus f equal to what? To 0. So this is the general form of each conic section which we are going to which we are going to have. So this is basically the general form. And then now from here, so whatever equation which we're going to have is going to be obtained from such here. So as you can see from here, that we have the x to the degree 2, y to the degree 2. Here our b is just 0 in our equation here. When you see b is just 0, so 0xy, of course, and then your d you have there 6, and then your e is 2, and then you have this constant, the f is a constant, that is the -17, and then equal to what? Equal to 0. So this here is the general form. So now, how do we get to what we want? How do we get to what we want? So what we do is you're going to be completing the square. So if you don't remember from math, it's 1100 and 1120 or 1110. I don't know which one you do, but then I hope you remember how to complete the square. So then you have x squared plus y squared plus y squared. So here I'm going to group those that have the x's together and those that have the y's together. So I have x squared, then I have 6x negative 6x, and then plus y squared, and then you have plus 2y minus 17 is equal to 0. So this is what you have. Now from here, just complete the square. Easy, right? So what we do when we're completing the square, you see here, you have the x. So you complete the square on the x, complete the square on the what? On the y. Yeah, separately like that. So you have for the x, I just get my square here. Where there's x square, just get the x. Then you have the coefficient of x. This without the square, there. The one without a square. The coefficient of x is just negative what? 6. So you divide that by what? 2. Or you half it. That is just dividing by 2 still. So negative 6 divided by 2 just gives us what? Negative 3. So like that. And then this square here comes outside. Like a squared, I put it outside there. Then I always say minus. So minus. And then what comes next is this here, the one I have, the answer of the half. So the negative 6, the one, then,
Yeah.
yes, yes, go on.
Why are we dividing 6
Why are we dividing 6 by 2? Is that your question?
by, yeah,
Okay.
yes.
We are dividing 6 by 2 because we are completing the square here. We are completing the square. I'm not writing all the steps. Like from math, what's this? I think, yeah, maybe we wrote all the steps. So here do you go like what? You always write x squared minus x like this, and then you say plus, what do you say? You say plus what? Plus 3 squared, then minus what? 3 squared, is it? When you're completing the square, you write it like this, right? And then you just say, oh, one of them, and then like that. So we are dividing by 2 here because we want to complete the square. I hope that's clear. Or
Yes.
maybe, okay, that's good. So now, so we say minus here. So in short, I'm giving you a quick step of how to do it without having to write so many steps that will not even gain you marks even if you write it. So when you are completing a square on the x, for example, here that we started, you have the one with a square, just write the x, look at the coefficient of the one with just x, divide it by 2. Then we get, in our case, negative 3. Write a minus sign there. Get a negative 3 that's here, a negative 3 like that, and then you square it. So that's how you would have completed the square on the one with the x. And then I go to the y. So plus here, the y, I write y. Then this one, well, with 2y, I divide by 2, that gives me 1. So I get plus what? 1, and then I square. And then minus, so 1 squared, like that, is still also going to be 1. Then minus the 17 is equal to what? To 0. So now, what are we going to do? From here, easy. So we just say x squared, x minus 3 squared, minus negative 3 squared. Since the power here is even, so I'll get a positive answer. So the minus is outside. This here becomes positive what? 9. And then plus, you have y plus 1 squared. 1 squared is just 1, minus 17. So now you add. So we're adding the negative 9, negative 1, negative what? 17. That just gives me negative 20 what? 7. So I have x minus 3 squared, then plus y plus 1 squared, then this equal to, so the negative 27, when it goes the other side, becomes what? Positive. So it becomes positive 27. So you have it like this. And then from here, what you do is you then write x minus 3 squared plus y plus 1 squared. And here, I'll write this as a what? As a root. That is going to be root of 27 squared. Root of what? 27 squared. So, okay, so that's what I get. Okay, so from here, now let me write the general form such that you get why I've written this as root of 27 squared. What's the square root of 27? Response?
Root of 10.
Huh? What's the square root of 27? That's the square root, right? Hello? Are people here?
Yeah.
We are following? Are we following?
Yes, we are.
Okay, okay, okay. Good, 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 good. So now, uh, as I said now, that uh, I write the general form. So the general form, I need to erase. Okay, let's do this. I create a new page. So now, let me take you to the general form. So if I have a circle, that's my circle there. Yeah, I know it's not the best, but then it's okay. So here my circle. From here, what you always, the basic way of how your circle is going to be is it will have a center. The circle has a center, right? Then that center, you can call it either x naught, y naught. That is x naught or y naught. Other books, you see them, they write hk. Any of them is going to be what should be okay. And then they're saying that from there to there, this point here is what is that point on each point here, since this circle here is going to be sitting on an xy plane. So meaning each point, that wherever point you're going to go from here to there, from there to there, let me use another color. So from here to there, from here to there, whatever point you're going to go to is just going to get x coordinates, what, x comma y. Now, and of course, they are going to be of what, the same distance. So now, these, now look at, this is where we make sense of the definition of the circle, that it's a set of points that are equidistant from what? From the center. So, from a given point, which is the center. So this point here, the center, this point here is of equal distance to the center. This point here to that point there is of equal distance to the center. So now, remember when you're doing the distance, so this here is just forming a line. So the distance of a line, uh, which we're just going to say distance d, let's call it d, and then you know that it's the square root of, so you have your x2 minus x1. So if we say this is our x1, that's our x2, so meaning we'll have, so I write this x1, y1, x2, y2. And then you have that this here, your x2 is just x. Your y what 2 is just what? This x naught. And then x squared. Then plus you have your y. So it's going to be y minus y naught, y squared. Now the distance, when you look at the distance here, that distance is just the distance, this distance from the center to any point in the circumference is just the radius. And so you see that this r distance here can just be equated to r, and then this whole thing here, which is x minus y naught x squared plus y minus y naught squared, like that. Then to get rid of this square, I just square both sides, right? Square there, I square there. Then I just have, I write it here, r is going to be equal to, I mean now it's r squared is going to be equal to x minus x naught squared plus y minus y naught squared. So this here becomes now the general equation of the circle. Now going back to where we were. So we are here. Where were you and where we were? So here, uh, that's the reason why we introduced what? The square root here, and then we squared it like that. So supposed to introduce the square root there. Just the root and not the square, just the root. Okay. Okay, so this here becomes our r squared, of course. So there, that becomes our what? Our r squared. So r squared is going to be that there. So what is our r now? So our r, if you see that we're squaring here, so again, I write the general form here, such that nobody gets lost, plus y minus y naught squared is equal to r squared. So it means this here, this one there, this 27 is the r squared. And here I've just rewritten it because I know that this square and that there, they cancel, they give me what? The 27. So now I've written it in a form where the square is outside, which is here, such that you know that the r is just what? 27. So our radius in this case is going to be root of what? 27. And root of 27 is just 3 root what? Root 3. So why is that important? So that is important. One, we've already identified. So where did we identified at this point here that this, because they're saying describe the conic section given. So one, we identified that, oh, this is a circle. By that there, we looked at it and said, okay, this is a circle since it has, it looks like the general form of our equation. Then number two, we have to find the center. The center, what is the center of our circle now? So the center of this circle is just going to be, what you do, you just get this x part and this y part, equate them to 0. So I say x minus 3 equal to 0. So this is going to be x equal to 3. And then I have the second part, that is y plus 1 equal to 0, and y is going to be equal to what? Negative 1. So my center is just going to be, so I write, so after writing all this, just write your center. Center is just going to be 3, comma what? Negative 1. That's your center. 3, comma negative 1. Your radius, radius we already found. So even radius indicate that your radius is just here, which is 3 root what? Root 3. That's your radius. So when you're describing a circle, what you just have to describe is, after you find the equation like that, you've completed a square and you've grouped like that, it looks like a general form, you find the center. After finding the center, find the radius and chapter. That's it. Okay, I don't know. Is there any question on how we do this before we look at another similar question? Is it clear? Can we move on?
Sorry, sir. I'm kind of confused where the square root of 27 is coming from because of squared it. Again, we've done the square root of it. So I'm
Okay.
kind of confused.
All right. So let us unconfuse you. So here, let me take you back to this part. So this part here, like that, right? First, okay, let me do this. So you have this part here. Yes, this same part that is here. So you agreed that this line, so let me name this line 1, and this last line here 2. These mean the same thing. Do you get that? That they just mean the same thing? That the line, I haven't changed the meaning of anything in that line. So line 1 and line 2 mean the same thing. Why? Because you know that the root of 27 squared is just equal to what? 27. This and that, you remain with 27. So meaning this line 1 and line 2 are the same. We did not change the why. But why did we write it in this form? We only wrote it in that form because I wanted you to see the r squared here, because the general form we said is this here, right? So it means when I'm done here, like here where I said, oh, x minus 3 squared plus y plus 1 squared is equal to 27. This 27 is the r squared. So in short, r squared is equal to what? 27, like that. So now, but then our radius is not r squared. Our radius is just r. So if you take the root here and take the square root there, of course, we're not taking plus minus here because we just have a need to have a positive answer for the radius. This here, the square root of what? Of 27. What's the square root of 27? So the square root of 27, you have that this is just, remember if I do 3 by 9, I get this, and this here is just going to be, I can separate them, root of 3, root of 9. Square root of 9 is 3, so I get 3, then the root 3 remains there, like that. So I get that r is equal to what? 3 root what? Root 3. That's where the 3 root 3 is what is coming from. Root 3 is the radius. So we said that for us to describe our circle, we need to find the center and we need to find the what? The radius. So we found the center by equating this to 0, which is 3 and negative 1. Negative 1. The 3 minus x minus 3 equal to 0. This gives us 3. Then y plus 1 equal to 0. This gives us 1. So our center is 3 comma negative 1. Then our radius, of course, is what we just explained. That's how you get your radius. Is it clear now?
Yeah, thank you.
Okay, you're welcome. Let's move on unless there's another question, but then this is the general form, we're just driving. We get back to here now. So they're telling us to find each of, for each of the circle with a given center and radius, then sketch. Well, you need to find the equation. Find the equation and then sketch it. Yeah, sketching is easy. You can actually start with sketching because you have your center. So let's say I draw my XY plane here. That's the Y, that's the X. The first one, for example, the first one, your center, they've said it's centered at 1, 0. So in your x-axis, you're moving what? To the 1. So 1 is here. In the y, you're not moving at any point because they said 0. So your center is here at that point. Then you know that, oh, a circle is of equal distance. So it means that every point where I'm going to move, I'm just going to move a radius of what? Of 1, because they said the radius is 1. So if I move to my left, it's going to reach 1. Up, down, wherever I'm going to move, I'm moving a distance of 1. So you know from here to there, the distance of 1, that's going to be 2. From here to there, that's going to be 0. So going up there, just pass it. Well, yeah, it's just a sketch, so pardon it like that. And so this is going to be, so from there to there, it's 0. Here it's at 0. So you know whatever point, this distance here, so you get the radius there is just 1. The radius is what? Is 1. So you've sketched it. So sketching is easy. And then to find the equation. So the equation, remember the general form for the circle. So for the circle, it was, we said x minus x naught squared, then plus y minus y naught squared is equal to what? To the radius squared, the radius squared. So you just replace. So x, what's my x naught? So your x naught is what? Is 1. So your 1 there is what you're going to put. So you say minus 1 here. Such that, you know, when you equate this x minus 1 to 0, it gives you 1, which is that point there. So yeah, you get it like that. And then you have your y here plus your y naught, I mean, your y naught is 0. So that's going to be 0 anyway. Just even if we write it like this, we know it's 0. Then your r is 1. So you put your 1 there and then you square it. So this here is going to be, I have the first, this part here, I can expand that, the x squared. So I'm going to expand that. That's going to give me x squared minus what? Minus 2x, right? Plus 1. And then you have plus y squared, and then you have your 1 there. So I can take the 1 this side, such that I have x squared minus 2x. This one comes to the left side, it becomes negative 1. It subtracts with this 1, which gives us 0. And then you have equal to 0 this side. So this here is going to be your equation. That is x squared minus 2x plus y squared is equal to 0. Doesn't matter how you write this, you can write x squared plus y squared minus 2x equal to 0. It's still going to be the same equation. Yeah, it's going to be the same equation, and it won't change anything. Right. Okay, so let's do the next question. In case somebody's lost, I'm sure they'll understand the next one. Okay, so next we begin with sketching. So, oh, it's analytical geometry and calculus. So the first part, we're going to do a lot of sketches and, equations, you drive, sketch. The sketches as I haven't even started. They'll start nicely. So these ones are nice sketches. The ones we're doing today are nice. We'll start those other ones later. So the radius is 2. First, the center is 1 comma negative 1. So this is at point 1. Let's say negative 1 is here, there. So that's going to be my what? My center. Then my radius is 2. So I know that when I move 2 steps this side, 1, 2, I'm going to land at 3. So this is 3. And I move this 1, 2 here, I'm going to land at negative 1. So those are the boundaries in the x-axis where my circle is going to what is going to face. And then in the x-axis, in the y-axis, you have, if this is 1, then you have 2. So maybe this is at point 2, like that. You expect it to pass through that point, something like that. And then there, like that. And then down there, like that. And there, passing at 3, like that. So your circle is going to look something like that. Yeah, I know here down it might not be accurate, but because of it's just the device I'm using. But I think on a pencil and a pen, you can draw it better down. Okay, so how do we then get our equation? So the equation is going to be, so we say x minus x naught. So what's our x naught? In this case, our x naught, that's 1. Then plus y minus the y naught is negative 1. So the negative by the negative will give us positive. So we get positive 1. And then you have r squared. So, I mean r, so our r is 2, but then we square because it's r squared this side. So, oh, and here we're squaring and there we're squaring. Yeah. So this here then gives you the first part, you're just gonna get, expand this, you get x squared, and then 2x. Sure, you know how to do this, just simple algebra. Plus then y squared plus 2y, and then you have plus 1, and then equal to 1 to 4. So there is going to be x squared. I want to say plus y squared. I can add these 2, that gives me 2. So minus 2y plus 2y. So that's going to be plus 2. The 4 goes the other side, becomes negative 4 equal to 0. And you have x squared plus y squared minus 2x plus 2y. This here is going to be negative 2 equal to 0. And that's the equation of your circle. Right, so yeah, I think you do the same here. Anyone who try this, you can try the last one. I'll do it, try it, send it to my inbox, and I'll check it if it's right or not. Yeah, but then that's it for today's class. Do you have any questions? Anyone who's behind? Anyone who's not following? Anyone with any question before we close the meeting for today, before we close it for today? Okay, so it's like nobody has any question. Right, so our services are offered fully online. So for those that would want to access our website, please do check it out. Let me just share my screen that everyone should be able to see. So how you do this is just go to your browser, and then as you open your browser, uh, discrete learning. So discretelearning.com, you find it there. Uh, so it's here, and then you can sign up for an account. If you don't have an account, sign up for an account, and then after signing up an account, you can register for any course that we offer. So we offer math courses. Um, Register for, so here, um, and also NS first year, those that are doing, or those that know people that will be doing. So you find it here, analytical geometry and calculus. So you then view your course here. So it will show you, then you have to sign in. If you don't have if you already have an account, if you don't have, make one, and then you can offer what, and then you can access the service that you need there. So when you open here, we have those past tutorial sheets. They are solved. Oh no.